Problem 49. Find the exact value of each of the remaining trigonometric function of theta, where cosine theta is given to be -1/3 and theta is in quadrant 3. There are two ways you can approach the problem, but in either way, first try to draw the picture of your angle. So I'm gonna try to draw a unit circle. Maybe I can just insert one here. Insert a unit circle. Okay. And then when you draw the angle, cosine is going to be the x-coordinate of the point on the unit circle when you draw the angle in standard position. The intersection, you look at the intersection of the terminal ray and the unit circle. So there are two such points. There are 2 points on the unit circle with x-coordinate -1/3. On top of that, we're told that your angle it lands in quadrant 3. So that allows us to rule out this possibility. And our angle has a terminal ray. The intersection of that terminal ray and the unit circle is this point. Therefore, the y-coordinate of that point is the sine theta we're looking for. So once you have this picture, you can do two things. One thing is, you can simply use the Pythagorean theorem. X squared and y squares on every point on the unit circle, when you add them up, the sum is going to be 1. In particular, if you take the x-coordinate of our point and the y-coordinate of our point, that happens to be sine theta, those squares will add up to 1. And 1/9 plus sine squared theta becomes 1. If I subtract 1/9, 1 minus 1/9, that's going to be sine squared theta, but 1 minus 1/9 is the same thing as 8/9. And when I take the square root, you have to be a little careful. Sine theta is going to be plus or minus square root of 8/9, or plus or minus square root of 8 over square root of 9. And square root of 9 is 3. And square root of 8, I can break it into, I can take that 4 out, or you can think about it like this. So it's nothing but 2√2. But theta is in quadrant 3. Therefore, sine theta is going to be a negative number. So that means our sine theta is going to be 2√2/3. Now, negative 2√2/3. Now, during this whole computation, I haven't worked with a specific theta. There is many angles. I don't really know what my theta is. There are many angles. When you draw them in standard position, they give the same terminal ray. That's fine. So we're not interested in what theta is. We're interested in what the trigonometric values of theta is. And no matter what theta is, if you draw it and this is the terminal ray, and the intersection is -1/3, something, and the terminal ray lies in quadrant 3, that angle will have this sign, -2√2/3. And then from here, you can figure out the other trig values. If you have sine and cosine, you have everybody else. For example, tangent theta would be sine theta over cosine theta, and that would be -2√2/3 divided by negative 1 over 3. The minuses cancel out each other, and then dividing by a fraction means multiply with the reciprocal, and these 3's cancel out each other, and you end up with 2 root 2. Cosecant theta, or maybe I should start with secant theta, is 1 over cosine theta. So that's going to be 1 over negative 1 over 3, and that would be just negative 3. Cosecant theta would be 1 over negative 2 root 2 over 3, and that would be negative 3 over 2 root 2. And since we're civilized people, we're going to rationalize our denominators. And cotangent theta is going to be 1 over tangent theta, and that's going to be 1 over 2 root 2. Again, I'm going to rationalize my denominator by enlarging it by square root of 2. Let me check my answer. If my answer key is correct. Just too many numbers, but they seem to be good. Okay. My preferred way of maybe dealing with this problem is I'm looking for a point let me try to draw it nicer. I'm looking for a point whose x-coordinate is negative 1 over 3, and it's on the unit circle. So what I would do is I would simply make my triangle bigger. So let's say this is it's a little tricky to draw things. Apparently something like that. That's something like negative 1 over 3. Okay, that intersection, let's say this is negative, it looks like 1 over 2, but it's not important to be that accurate. And I want to make this actually longer. So instead of working with this triangle, I would make it 3 times as large. So this side becomes 3 units instead of 1. Then this side will become negative 1. And then this side, again, I can use the Pythagorean Pythagorean theorem. So a square plus negative 1 square is 3 square. So a square equals to a square plus 1 equals to 9. A square is 8. A is plus or minus 2 root 2. Since I know a is negative, I'm going to go with negative 2 root 2. And then I can shrink a, make it 3 times as short as before, because I made my triangle 3 times as big to not to deal with fractions. Over 3. And then from here on, the solution would be the same once you have cosine theta and sine theta. That's all I want to say about this question.